Welcome to day 3. For your homework, you have some textbook problems and then also a calendar problem, so be sure to do both. Here's some of your homework solutions, so you can pause it at this point. Check your answers, and I'll scroll down in a couple seconds to get that last one. So again, you can pause, check all your answers, and then I will pause for about 10 seconds on each of the worked out solutions. So if you need to check any of those, you can. Now feel free to skip ahead in the video to whichever ones you need to check. You don't need to sit here for the ones that you got correct. In 12, note rewrote it as 2x times e to the negative x, and that made it a mismatched product, which allowed us to do integration by parts. Note 18 was not integration by parts. You could do that one just with u substitution. And 25, you had an option. You could do u substitution where we have that extra substitution. So u could equal x minus 1. That would give you square root of u. But you have that leftover x, so get the x by itself, and that's u plus 1. Distribute the square root of u through, and then you could do your antiderivative and fill back in for u. Or you could have done it with integration by parts. Let the u equal x, your du would be the square root of x minus 1. Now you get two different answers there based on how they look. But if you neaten them up, if you pulled out an x minus 1 to the 3/2 out of each of them, and then neatened up the insides, they do end up matching up. Number 30, you had to do repeated integration by parts. You ended up with 2 integration by parts you had to do. And in 33, you did an integration by parts. Your dv was just the dx, that was our only leftover stuff. And then that second integral, we had to do a u substitution. So you only need up to the boxed answers for parts A and B here. The work after that was I was just going through, kind of like in 25, to show you that either method produces an equivalent answer. But the boxed answer is perfectly fine for full credit for either of those. And then the area bound by the graph just ends up being that integral. So you've got just integration by parts, and then you've just got to fill in the numbers. I would suggest not to fill in the numbers until you have done the entire integration by parts. So notice I didn't sub in that 0 and 4 to the negative x e to the negative x until the very end after you had resolved the entire integral. All right, so in our notes packets, we're going to look at just 4 examples. This is in the day 3 in the notes packet. We're going to look at 4 more challenging integration by parts examples. So this first one is the actual integration by parts is not hard, but recognizing this as integration by parts is challenging. A lot of people tend to get stuck on this integral, and it's a common one that shows up. So what we want to recognize is it is a mismatched product. We're really doing natural log of x times dx. And we don't have any antiderivative rule just for natural log of x. So if we go through our hierarchy of ones to pick for u, we have a log. So we don't get that far. Remember, this is log, inverse trig, polynomial. The polynomial could be a monomial, exponential, and then trig. So our u wants to be natural log of x, meaning our dv, our leftover, is just dx. Du would be 1 over x, and the antiderivative of dx for our v would just be x. And just as a reminder, we're doing uv minus the integral of v du. So we'll have x natural log of x minus the integral v times du. Oh, you know what? I forgot my dx on that there. V times du will be x times 1 over x dx. Well, x times 1 over x is just 1, so this will just end up as dx. The antiderivative of dx is just x, so we'll have x ln x minus x, and then your plus c on the end because it is an indefinite integral. So once you have the integration by parts set up, not the hardest one in the world, but recognizing its integration by parts is the tricky part in that one. So repeated integration by parts. You saw a preview of this on that one homework problem. So we've got a mismatched product here because there's not anything you can let equal u, and then the leftover is your du. So that's what would lead us to think this is integration by parts. If we go through our hierarchy for u, we do not have any logs. We do not have any inverse trig. But we do have a polynomial, or in other words, a monomial. We have the x squared. So our dv would be e to the x dx. U's derivative du would be 2x dx. And e to the x's antiderivative for v is just e to the x. So we'll do our uv minus the integral of v du. So uv is just going to give us x squared e to the x minus our integral of v du. We'll have e to the x times 2x. So that's minus the integral of 2x e to the x, and we have our dx as well. Well, that's still a mismatched product. Okay, 2 to the x and e to the x, there's nothing you can let equal u and have the leftover match up. So we've got to do integration by parts again. For u, there's still no trig, there's still no logs, there's still no inverse trig, but 2x is like a polynomial. So our dv, again, is going to be e to the x dx. So our du now will just be 2 dx, and then v will be e to the x. Now, the thing you have to be careful about here is that minus is going to have to distribute through to the entire thing that we get for this integral. So we're going to have x squared e to the x minus, and then start a parenthesis. We'll have our uv, so that'll be 2x e to the x minus the integral of v du. So that'll be 2 e to the x dx. So I'm going to go ahead and distribute my negatives. This is x squared e to the x minus 2x e to the x, now plus the integral of 2 e to the x dx. Well, 2 is just a coefficient. Antiderivative e to the x is just e to the x. So this is going to end up as plus 2 e to the x plus c. And then we'll just carry everything else down. So sometimes you might have multiple integration by parts that you have to do in order to resolve your integral. All right, so we'll get even more challenging. So the full circle case. We want to recognize this is a mismatched product. There's nothing you can just let equal u and have the du match up with the other stuff. So that's what would lead us to try integration by parts. There is no logs. There's no inverse trig. There's no polynomials. So the u, the first thing it would make sense to be is the exponential. So we'll let u equal e to the x, and dv will be the sine x dx. Our du will be e to the x dx. And our antiderivative sign for v would just be negative cos x. So this will give us negative e to the x cos x for our uv. And when we do minus, our v du will be minus cos x e to the x. Well, we can pull that minus out front, and it'll make it plus cos x times e to the x dx. Well, this is again a mismatched product. So we'll let u equal e to the x again. dv will now be cos x dx. Our derivative of e to the x is just e to the x dx. And our antiderivative of cos is just sine x. So if we carry down, we've got minus e to the x cos x plus our uv would be e to the x sine x minus our integral of v du. So it's going to be minus the integral of e to the x sine x dx. So what you want to notice at this point is the integral we have is the same as the original. So we've just gone in a circle. So what we have written in purple there should equal the original integral. So we're going to write this as an equation now. Here's our original integral. So integral of e to the x sine x dx, we know is equal to minus e to the x cos x plus e to the x sine x minus the integral of e to the x sine x dx. And what we're going to do is we're just going to collect all those integrals on the same side. So we're going to add this integral to the other side. So we now really have two of that integral. We'll carry down all the leftover stuff on the right side. And what the problem really wanted to know is, what is the integral of e to the x sine x dx? Well, just divide the 2 over, and that'll tell us now. So we've got the integral of e to the sine x dx is equal to, we'll have negative 1/2 e to the x cos x plus 1/2 e to the x sine x. And then the tricky thing you have to remember, because we never did that final integral on the right side, is this is an indefinite integral. So we would need a plus c on the end eventually. And I distributed that 1/2 through. You could have left it as 1/2 and just put it all in parentheses. That would have been fine as well. So that's a tricky one. That's the cycle case. And you would recognize that if eventually you get back to the integral you started with. Well, if you get that, set it equal to the original integral. Collect those original integrals all on the same side, and then divide over to get that original integral by itself. All right, one last challenging example for today. So we do integration by parts when we have a mismatched product. And what we mean by a mismatched product is if you let u equal something, its leftover is not present. Well, instead of u, and you'll see why I'm doing this in a second, let's let t equal x to the third to try this with like a normal u substitution. Well, then dt would have to equal 3x squared dx. Well, this original integral, we could really write it as x squared times x cubed e to the x cubed dx. Well, if we multiply both sides by a third dt would just be equal to x squared dx. So we can actually do a change of variable, a substitution, in this case a t substitution, and that might make it a little bit more manageable. So the e to the x cubed is now going to become e to the t. The x squared dx is now going to be 1/3 dt. So I'm going to put the 1/3 out front here. Here's the dt. And then we still have x cubed left. But x cubed was t. So we have 1/3 t e to the t. Well, that is still a mismatched product, but it's a little bit more manageable. So now we can do integration by parts. There's no logs, there's no inverse trig, so our monomial, like a polynomial, we would let u equal to t. Our dv would be the e to the t dt. du would be equal to just 1 dt. And then the antiderivative e to the t for v is just e to the t. So this is going to be 1/3, and I'm just going to throw a parenthesis, and we'll worry about the 1/3 in a second. We'll have our uv, so we'll have t e to the t, minus the integral of v du, so that's just minus integral of e to the t dt. And that's something that's pretty easy. Antiderivative e to the t is just itself. So we'll have t e to the t minus e to the t plus c. We can distribute that 1/3 through now. Now a third times a constant is still just some constant. But we need to keep in mind that the original variable in the integral was x. So t is really x cubed. So we need to replace in the end all of these t's with x cubes. And that's the most complicated version that would eventually lead to integration by parts. You had a strange substitution to begin with, and then that led to integration by parts. So that's it for this video. Feel free to stop into office hours if you had questions on anything. Have a great rest of your day.